All right, next one. We got H2O. Most of us know the common name. Common name for this is gonna be, you got it, agua. Agua purificada, water. Now the actual nomenclature or the name for water, right? We would call it, well, the first element is hydrogen, but don't forget we have a 2 right here, so we gotta name the prefix. The prefix for 2 is gonna be di. So it'll be di, and we're gonna name the first element as is, so it's gonna be dihydrogen. All right, and we got a second element right here, it's oxygen, but it's missing a subscript, so we have to assume that it is at least 1. The prefix for 1 is gonna be mono, and then oxide for oxygen. Okay, so therefore the name for H2O, which is water, the common name, here we have dihydrogen monoxide. All right, so now we're gonna do the Lewis structure. We have been accustomed from the previous examples that the first element was what? The central atom. But in this case, it is not the first element that is the central atom, it's actually this one, because it's the one with the least number of atoms. This one has 1 and this one has 2. So that means that oxygen is gonna go in the middle, so don't get confused. So we're gonna put O in the middle. Now if you look at O, we have to find out how many valence electrons and represent them by dots. So how many valence electrons does oxygen have? Oxygen has 6 valence electrons. Okay, so 1, 2, 3, 4, 5, 6. Now here in this situation, right, we have 2 H's. Well, we're gonna put the H's where the single electrons are. Right there and right there. Hydrogen has only 1 electron, so that 1 electron is the valence electron. Again, what are we gonna do? We're gonna connect the dots, and we're gonna end up with here 2 lone pairs of electrons. Yes, it does have 2 sides. So if you didn't draw it exactly as this, right, and you put, the lone pair down here and the one single and the other single, you might see a line. So you might be implicated to right away say, oh, this one's linear, because you drew a different conformation. Now that's not the case. Because of these lone pairs of electrons, they're going to change the conformation of that molecule, so it is not going to be linear. It's actually going to be what? Anybody? Bent. Okay. For this bent molecule, now we added, if you notice here, look, we went from tetrahedral for 109, so we replaced one of the bonds with a lone pair of electrons, and the bond angle went down. So guess what? We replaced again another bond with another lone pair of electrons, so it is gonna go even down further. All right, last thing. How many vicinal atoms does oxygen have? Well, here you see 1 and 2. So therefore, you will put it right there.